In this video, I will review the practical exercise we started before. So for this, we've used a template basic usage of plots2_stud_further.ipynb. And we've already initiated the work by filling the first cell. So in the first cell, we want to tell which packages we are going to use. And the basic one is plots. And what we installed during the session was a package called lazy grids. So if everything works well, you should be able to load both packages in the same command here, and you get the green tick mark. The first exercise was to plot the interfaces inside the Earth, and for this we will use our experience with drawing circles. So we want to draw basically 4 interfaces. One will be the surface of the Earth with a radius of 6,400 kilometers. The inner core has a radius of 1,200 kilometers. The outer core has a thickness of 2,200 kilometers, and the mantle with a thickness of 2,900 kilometers. To draw these circles, we will use the equation of a circle in parametric form. So we will compute x is equal r cosine theta and y is equal r cosine theta. And basically, we want to change r according to the interface of interest. So what we did, we defined an angle, theta, ranging from 0 to 2 pi, here with 100 points. And we define all the radii. So the surface is basically this number directly. And then we needed to compute the top of the mantle. To compute the top of the mantle, remember, we had to start from the inside. So we take the radius of the inner core. We had the thickness of the outer core and the thickness of the mantle. This will give us the value of the radius for the top of the mantle. Same applies to the outer core. Radius of the inner core plus radius of the outer core. And last, radius is the radius of the inner core, which is basically what is given here. So what we did, we used the equation of a circle. So we define x and y using the radius corresponding to each of the interfaces. The first plot here is done without exclamation mark because we're starting a clean plot. And then each of the 3 additional interfaces are plotted using plot exclamation mark, such that we draw on top of it. Additionally, I introduced optional keyword argument for plots. So here you can use labels, X labels, Y labels. This we did already in the first lecture, but then you can change the color manually. You can control the width of your line, the style of your line. There are lots of possibilities. So that was the final figure. So to create this figure, we have drawn the lines like you would draw with your hand. So we only color the interface. In the second part of the exercise, I ask you to create a 2D image, a pixel map, which would represent the same information. So the first step would be to create 2 axes in x and y. So both axes will vary from minus 8,000 kilometers to 8,000 kilometers and will be defined with 1,000 points. Then we would use the function ndgrid from the lazy grid package to generate 2 2D coordinates, 2D x, y coordinates from the 1D array x and y defined above. Then we need to create a table which will be initially full of zeros. We will make a 2D table full of zeros, and we will then identify which pixels inside this 2D table correspond to which layer. And to do this activity, we now use the equation of a circle in non-parametric form. So we will use this form of equation. And finally, we will visualize the result using what is called the heat map. So let's start with the first part of the exercise, which is creating the two axes. So we can make x is a linear range from minus 8,000 to 8,000 with 1,000 points. Y will be also a linear range going from minus 8,000 to 8,000 with 1,000 points. So here the unit is in kilometer to make it clear. And now both of these arrays are 1D. And we want to create a 2D arrays out of this 1D. So we can define x2 and y2 in brackets is ND grid of x and y. So this function ND grid, it will take the 1D array x and the 1D array y, and it will spit out two 2D tables, x2 and y2, that contains the coordinate of each of the pixels in the map. So these are 2D coordinates now. So that's the generation of a from 1D to 2D coordinate, from 1D axis to 2D coordinates. And that's where we basically use this lazy grid. Now we want to make a 2D table full of zeros. So let's call this table C zeros. And of course, we want the size of this array to be corresponding to the size of x2 and y2. So x has 1,000 pixels, y has 1,000 pixels, x2 will be 1,000 by 1,000, y2 will be 1,000 by 1,000. So let's simply type 1,000 by 1,000. So this step is done. And now we want to identify in which part of C we have which layer. So let's try to identify all the pixels of C that are contained below the surface of the Earth. So to do this, we use the equation of the circle again. Coordinate x square plus coordinate y square should be equal to the radius square. So if we want to be below the surface, we will use the sign inferior or equal. So here I'll show you a compact way to do this. We take C and we will search for all the indices within C that will be contained below the circle that defines the surface of the Earth. So we will take the coordinate x2 and we will set it to the power 2. So here it's an array, so when we take the power, we need to use a point here. So point power 2. Let's do the same for y. So we will add y 2 to the power 2. And now we want this to be, we want the pixels to be contained within the radius. So now we set r surface to the power 2. R surface is a scalar, so we don't need to use a point here. So let's identify this with a number. So all the points that will be within the circle will receive the value, let's say 1. So let's run this. And let's already make a figure. So we will make a heat map now. So you will see directly what a heat map is. So a heat map will receive 3 basic arguments: the x coordinate, the y coordinate, and the field you want to visualize. And here it will be C. Let's run it. Wow, there we go. Again, it looks a bit like an egg because the axes are not to scale, so we need to set the aspect ratio is equal to 1. Now we get a beautiful circle. So what you see now is basically the space going from minus 8,000 kilometers to 8,000 kilometers, same in y. All the pixels which were initially set to the value of 0. So this is the color map corresponding to this. And all the pixels here contained within the radius receive the value 1. So they're displayed with a yellow color. So we've managed to make one of the interface. So let's do it for the others. So let's do the mantle and let's set it to the value 2. Let's go our mantle. There we go. So we see a very thin crust of red color. Now the value 2 is inside. You see that the color map maximum value is 2. And let's do it for the inner and the outer core. With the number 3 and the number 4. There we go. Now we have all the layers we wanted to have initially. So we created a similar figure as this one. So for this one we used the parametric form and we only displayed the lines. While to create this figure we've used the equation of the circle in non-parametric form, and we have colored the pixels, not the interfaces. And for this, we had to learn how to access an array and how to use a heat map. So in the next lecture, I will give you more information about arrays and vectors in general. But this is already a nice introduction to this. So thanks a lot for your attention.